Hello, I'm Maruk Said, your microbiology guide. Let's explore in-depth micro techniques and uncover groundbreaking insight together on this educational journey into the fascinating realms of microbes.
Groundwater and surface water pollution. Sources, effects, and solutions. Table of contents. Introduction to water pollution. Sources of water pollution. Types of water pollutants. Types of water pollution. Effects of water pollution. Solutions and prevention of water pollution. Introduction to water pollution. Water pollution is a growing global issue that poses significant risks to ecosystems, human health, and vital water resources. It primarily results from the contamination of water bodies with hazardous substances like toxic chemicals, pathogens, and waste materials, rendering them unsuitable for human consumption and harmful to aquatic life. As populations grow and industrial activities increase, pollution levels intensify, putting immense strain on water quality. The World Health Organization, WHO, reports that millions of people lack access to clean water and adequate sanitation, leading to serious health issues, particularly in developing nations. Pollutants are spread through the water cycle, impacting local environments and essential water resources used for drinking, agriculture, and industry. With 80% of global wastewater left untreated, the urgent need for action to address water pollution is critical to safeguarding both human communities and the natural environment. Sources of water pollution. Water pollution sources can generally be classified into three main categories. Number 1, point sources. Number 2, non-point sources. Number 3, transboundary sources. First, point source pollution. Point source pollution originates from a single identifiable location where contaminants are directly released into a water body. This type of pollution is easier to monitor and regulate because the source of contamination can be precisely traced. Examples: industrial discharges. Factories, refineries, and power plants often discharge waste through pipes or channels into rivers, lakes, or oceans. These effluents, which frequently contain chemicals or heavy metals, degrade the quality of aquatic ecosystems. Sewage treatment plants. During heavy rainfall or technical malfunctions, untreated or partially treated wastewater from these plants can overflow into nearby water bodies. Combined sewer systems, which handle both stormwater and sewage, are prone to such overflows. Animal factory farms. Concentrated animal feeding operations, CAFOs, housing large numbers of livestock, such as cows, pigs, and chickens, produce significant amounts of waste, which can flow directly into nearby water sources, similar to untreated sewage. The U.S. Environmental Protection Agency regulates point source pollution through the Clean Water Act by setting limits on the pollutants that facilities can discharge. However, challenges arise when these standards are not met, or incidents like spills occur. Second, non-point source pollution. Non-point source pollution results from a broad accumulation of pollutants over large areas being washed into water bodies, making it more difficult to trace and control compared to point source pollution. Examples: agricultural runoff. Water from rain or irrigation picks up fertilizers, pesticides, and herbicides from farmlands and carries them to rivers, lakes, or groundwater. Excess nutrients from fertilizers can cause eutrophication, leading to harmful algal blooms and oxygen depletion in aquatic ecosystems. Urban runoff. Stormwater runoff from streets, parking lots, and construction sites in urban areas carries oil, grease, heavy metals, and chemicals into storm drains and waterways. This is a significant source of pollution in densely populated regions. Abandoned mines. Rainwater flowing through inactive mining sites can pick up acids and toxic heavy metals, which then leach into nearby water systems. These toxic elements can persist in the environment, negatively impacting water quality and aquatic life. Atmospheric deposition. Airborne pollutants from industrial emissions and vehicle exhaust can enter water bodies through rainfall, commonly known as acid rain. Pollutants like sulfur dioxide and nitrogen oxides, primarily from power plants and vehicles, contribute to this type of pollution. Non-point source pollution is harder to regulate since it is widespread and involves numerous small contributors. Third, transboundary pollution. Water pollution can cross political boundaries, with contaminated water from one country flowing into the waters of another. This type of pollution can result from sudden large-scale disasters or long-term industrial or agricultural runoff. Examples: oil spills. An oil spill in the waters of one country can spread, contaminating the waters and ecosystems of neighboring nations. Oil slicks can travel vast distances, affecting marine life and coastal communities. Downriver contamination. Pollutants from industries or farms upstream can flow downstream into other regions or countries. Rivers that cross international borders can carry industrial waste, agricultural runoff, or untreated sewage into neighboring countries, often causing disputes over water quality and resource management. Managing transboundary pollution requires international cooperation through treaties and agreements, as countries must work together to protect shared water resources. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Types of water pollutants. 1. Organic pollutants. 2. Inorganic pollutants. 3. Microbial pollutants. 4. Radioactive pollutants. 1. Organic pollutants. Organic pollutants are carbon-based compounds that persist in the environment and can accumulate through the food chain, leading to the buildup of toxic substances in both wildlife and humans. Sources: agricultural runoff. Pesticides, herbicides, and fertilizers are washed into water bodies by rainfall or irrigation. Industrial discharges. Factories and industrial plants release chemical byproducts directly into rivers and lakes. Examples include pesticides, solvents, and industrial chemicals such as dioxins, persistent organic pollutants, POPs, such as dichlorodiphenyl trichloroethane, dioxins, heavy metals, mercury, and lead, pharmaceuticals, personal care products. Effects: toxic to aquatic ecosystems, disrupting hormonal balance in wildlife. POPs accumulate along the food chain, causing long-term health problems such as cancer, reproductive disorders, and neurological damage. Contributes to the development of antibiotic resistance in microbial communities, posing risks to public health. 2. Inorganic pollutants. Inorganic pollutants are non-biodegradable and can persist in water systems for extended periods, posing serious environmental and health risks. Sources: industrial processes, mining activities, and agricultural activities in the form of fertilizers. Industrial processes. Factories and mining activities release heavy metals and toxic chemicals into water. Agricultural fertilizers. Fertilizers contribute to nitrate and phosphate runoff into water bodies. Examples: heavy metals like lead, mercury, and arsenic, nitrates and phosphates. Effects: heavy metals bioaccumulate in living organisms, leading to toxic effects such as organ damage and neurological disorders. Nutrient pollution from nitrates and phosphates causes eutrophication, depleting oxygen levels in water bodies and promoting harmful algal blooms. Microplastics accumulate in marine environments, harming aquatic life. 3. Microbial pollutants. Microbial pollutants are a major public health concern, especially in regions lacking proper wastewater treatment. Sources: human and animal waste, untreated sewage, and agricultural runoff. Examples: bacteria such as E. coli, viruses, and protozoa. Effects: waterborne diseases like cholera, dysentery, and typhoid are caused by pathogens in contaminated water. These pollutants are particularly dangerous in areas with poor sanitation. 4. Radioactive pollutants. Radioactive pollutants are among the most hazardous substances, as radioactive contamination can persist for thousands of years. Sources: uranium mining, nuclear power plants, and medical research activities. Effects: long-term contamination of both groundwater and surface water by radioactive materials leads to severe health impacts, including cancer and genetic mutations. Types of water pollution. The quality and safety of water bodies such as rivers, lakes, seas, and groundwater are all impacted by water pollution, which poses major dangers to human health and the environment. Key categories of water contamination include the following: 1. Groundwater pollution. 2. Chemical pollution. 3. Nutrient pollution. 4. Microbiological pollution. 5. Suspended matter pollution. 6. Thermal pollution. 7. Oxygen depletion pollution. 8. Surface water pollution. 1. Groundwater pollution. Description: groundwater stored in underground aquifers is vital for drinking water, especially in rural areas. Pollution occurs when harmful substances seep into these reserves, making cleanup difficult due to slow filtration and long residence times. Sources: agricultural runoff, pesticides, fertilizers, leakage from septic tanks and sewage systems, chemical spills, landfills, and fossil fuel extraction. Common pollutants: nitrates, pesticides, volatile organic compounds, and petroleum products. Impact: contaminants like nitrates, heavy metals, and pathogens make groundwater unsafe for consumption and agriculture, posing long-term challenges for affected communities. 2. Chemical pollution. Description: this widespread pollution occurs when hazardous chemicals enter water bodies, causing immediate or long-term toxic effects on both human health and aquatic life. Sources: industrial discharges, agricultural runoff, pesticides, fertilizers, mining operations, improper household chemical disposal. Common contaminants: arsenic, lead, mercury, PFAS, fracking fluids, nitrogen, and chlorinated disinfection byproducts. Impact: accumulation of these pollutants in water supplies can cause serious health problems such as cancer, neurological damage, reproductive issues, and can poison aquatic ecosystems. 3. Nutrient pollution. Description: excess nitrogen and phosphorus in water bodies stimulate harmful algae growth, disrupting aquatic ecosystems. Sources: agricultural fertilizers, wastewater, detergents, and livestock waste. Impact: algal blooms block sunlight, deplete oxygen, and kill aquatic life. Some algae release toxins that degrade water quality and threaten human and animal health. 4. Microbiological pollution. Description: this type of pollution involves harmful microorganisms like bacteria, viruses, and protozoa contaminating water, leading to diseases when consumed or used for bathing and irrigation. Sources: human and animal waste, agricultural runoff, untreated sewage, and stormwater. Impact: common in areas with poor sanitation, this pollution leads to outbreaks of waterborne diseases like cholera, dysentery, and typhoid. 5. Suspended matter pollution. Description: pollutants that do not dissolve in water remain as suspended solids or particles, negatively affecting water quality. Sources: erosion, agricultural runoff, industrial discharges, and algae blooms. Impact: suspended particles settle on the waterbed, smothering aquatic habitats, while floating particles reduce oxygen and impair photosynthesis, threatening aquatic species. 6. Thermal pollution. Description: temperature changes in water, usually caused by human activities, can severely impact aquatic ecosystems. Sources: heated water discharges from industrial facilities, power plants, and deforestation that removes shade from water bodies. Impact: temperature fluctuations reduce oxygen levels in water, stressing or killing fish and other aquatic life, while also encouraging harmful bacterial and algae growth. 7. Oxygen depletion pollution. Description: excess organic matter decomposes in water, consuming oxygen and causing eutrophication, which depletes oxygen levels. Sources: agricultural runoff, wastewater containing organic material, and nutrient-driven algal blooms. Impact: dead zones form where aquatic life cannot survive due to low oxygen levels, altering ecosystems and threatening biodiversity. Oxygen-demanding waste and its impact on water pollution. A. Biochemical oxygen demand, BOD. Definition: BOD measures the amount of oxygen consumed by aerobic bacteria as they break down organic matter in water. High BOD indicates elevated levels of organic pollutants, which leads to oxygen depletion. Sources: primary contributors include sewage, agricultural runoff, and decaying plant material like leaves and grass. Impact on ecosystems: excessive oxygen-demanding waste lowers dissolved oxygen levels, causing hypoxia. This can be fatal for oxygen-sensitive aquatic species like trout, while more resilient species like carp and catfish may survive in low oxygen conditions, below 5 ppm. B. Eutrophication and its effects. Definition: eutrophication occurs when water bodies become overly enriched with nutrients, primarily nitrogen and phosphorus, promoting excessive growth of plants and algae. Harmful algal blooms. Algal overgrowth can block sunlight, obstruct fish gills, and deplete oxygen as the algae decompose. Some algae produce toxins harmful to aquatic life, livestock, and humans. Decomposition creates hypoxic zones, or dead zones, with oxygen levels below 2 ppm, which are uninhabitable for most marine organisms. Notable hypoxic zones have formed in lakes, rivers, and coastal regions, such as the Gulf of Mexico. 8. Surface water pollution. Description: this form of pollution affects visible bodies of water like lakes, rivers, and oceans, stemming from direct discharges, point sources, or runoff, non-point sources. Sources: industrial waste, untreated sewage, agricultural runoff, litter, and oil spills. Impact: surface water pollution lowers water quality, harms aquatic life, and renders the water unsafe for drinking, fishing, and recreational activities. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Effects of water pollution. 1. Impact on human health. 2. Environmental impact. 1. Impact on human health. Waterborne diseases. Contaminated water is a leading cause of illnesses such as cholera, typhoid, and giardia. According to the WHO, 80% of global diseases are linked to poor water quality. Children, particularly in low-income regions, are most vulnerable, contributing to high infant mortality rates. Toxins in drinking water. Heavy metals like arsenic and mercury, along with pesticides, often contaminate drinking water, leading to severe health problems such as hormonal imbalances, cancer, and developmental issues in children. Swimming hazards. Contact with water contaminated by sewage can cause skin rashes, eye infections, respiratory issues, and diseases like hepatitis. Long-term consequences. Poor water quality and inadequate sanitation contribute to malnutrition and gastrointestinal diseases, weakening the immune system and stunting growth, especially in children. 2. Environmental impact. Ecosystem imbalance. Water pollution disturbs aquatic ecosystems. Toxic chemicals and heavy metals reduce the lifespan and reproductive capacity of aquatic organisms. Fish like tuna accumulate harmful substances like mercury, which can make them unsafe for human consumption. Algal blooms. Excessive nutrients from pollution cause algal blooms, which deplete oxygen levels in the water, creating dead zones where aquatic life cannot survive. Some blooms release neurotoxins, which are harmful to marine animals such as whales and turtles. Marine debris. Plastics and other waste contaminate oceans, putting marine life at risk. Animals can become entangled, suffocated, or ingest debris, leading to starvation and death. Ocean acidification. The absorption of excess carbon dioxide from fossil fuel emissions makes oceans more acidic. This weakens coral reefs and shellfish populations, threatening the broader marine ecosystem. Water pollution presents serious threats to both human health and environmental sustainability, emphasizing the urgent need for improved water quality and access to proper sanitation. Solutions and prevention of water pollution. 1. Individual actions to prevent water pollution. 2. Advocacy and policy support. 3. Technological solutions for water pollution. 4. Education and public awareness. 5. International collaboration. 1. Individual actions to prevent water pollution. Reduce plastic usage. Reducing plastic consumption and focusing on recycling or reusing plastic items can help decrease water pollution caused by plastic waste. Proper waste disposal. Dispose of chemical cleaners, oils, and non-biodegradable products correctly instead of flushing them, preventing harmful chemicals from entering the water system. Vehicle maintenance. Regularly maintain your vehicle to avoid leaks of oil, antifreeze, or coolant, which can wash into storm drains and pollute local water sources. Landscaping and gardening. Design gardens to minimize runoff and refrain from using chemical pesticides and herbicides, which can end up in stormwater systems. Safe medication disposal. Dispose of unused medications in the trash rather than flushing them to prevent pharmaceuticals from contaminating water supplies. Pet waste management. Properly dispose of pet waste, which contains harmful bacteria that can be washed into water systems during rain. Conserve water. Simple practices like fixing leaks, using water-efficient appliances, and conserving water in daily tasks reduce the strain on water treatment facilities and lower pollution levels. 2. Advocacy and policy support. Support clean water laws. Advocate for environmental policies such as the Clean Water Act, which holds industries accountable for water pollution and ensures the maintenance of clean water systems. Modernize regulations. Push for updated regulations that address new water pollutants like microplastics, PFAS, pharmaceuticals, and other contaminants that older treatment systems were not designed to manage. Invest in water infrastructure. Support government efforts to upgrade water infrastructure, including wastewater treatment facilities, lead pipe replacement programs, and green infrastructure for managing stormwater. Community involvement. Participate in local decision-making and encourage others to get involved. Public waterways are shared resources, and community engagement can help foster effective solutions. 3. Technological solutions for water pollution. Wastewater treatment. Modern wastewater treatment plants use advanced filtration and biological processes to remove pollutants before water is returned to the environment. Technologies like membrane bioreactors, MBRs, and UV disinfection are enhancing efficiency. Green infrastructure. Solutions like green roofs, permeable pavements, and rain gardens help capture and filter stormwater before it enters water systems, reducing urban runoff pollution. Phytoremediation. Certain plants can absorb pollutants from contaminated water and soil, making phytoremediation a promising technique for cleaning polluted water bodies. desalination, and advanced filtration. Technologies like reverse osmosis and desalination plants provide fresh water in areas with limited resources, offering a way to treat seawater or brackish water for safe use. 4. Education and public awareness. Public campaigns. Raising awareness through public campaigns is key to reducing water pollution. Educating communities about proper waste disposal, water conservation, and sustainable agricultural practices can encourage more environmentally responsible behavior. School programs. Introducing water conservation and pollution prevention topics in schools can educate younger generations on sustainable practices and the importance of maintaining clean water for health and ecosystems. 5. International collaboration. Global initiatives. Organizations like the United Nations, WHO, and various NGOs work globally to tackle water pollution by promoting Sustainable Development Goals, SDGs, especially SDG 6, which focuses on clean water and sanitation for all. Sharing technology and expertise. Developed nations can assist developing countries by sharing technology and expertise to improve their water treatment infrastructure and reduce pollution more effectively. Preventing and solving water pollution requires collaborative efforts from individuals, communities, policymakers, and industries. By adopting sustainable practices and advocating for stronger environmental protections, we can preserve water quality for future generations. Thank you so much for watching. Don't forget to subscribe to my channel, press the bell icon button. Thank you!